Some of you are still struggling, I think so. And please guys work hard. But overall, I think you guys did really good job in the exam. Couple guys, not couple, I would say 3, 1, 2, and yeah, 2 guys. They didn't do well. Otherwise, all you guys, fantastic job, guys. Most of you guys are above 85%. That sounds really good. That's really good. Only 2, 3 guys didn't do well. So please guys, please work hard. And I think you guys are on track now. That's what I was expecting. The class average is also more than 80, 82.7. So that sounds good. Just give it up, guys.
So I have a quick question.
Let me finish first, please. Don't interrupt me. And what I was trying to, class average is 82.7. And last 2 exams are left out. One is your internal last exam, and then after the final. So I think those who are on the boundary, the maximum chances are there to cross the boundary. I mean to say, suppose somebody is on 78 or like this, maximum chances are there so that he or she can cross the boundary. He or she can go for 80 plus. Just the same for A grade, same for C grades, those who think that they are on the boundary of C. So please work hard, guys, and I'm here to help you out. Right, guys? So that's the only thing I wanted to let you know. Yes, who was there? Any question? Soto?
Soto, yeah, I'll just ask you after class, sir. Sorry.
Say again?
I'll just ask after class. It'll be easier.
Oh, okay, okay,
Thank you,
fine. No problem, yeah. Don't forget, okay?
Yes, sir.
Okay, yeah. Actually, I also wanted to talk to you. Yesterday I went through, etc. Right? I don't want to discuss anything right now. We will discuss after the class when everyone will be out of Zoom. Okay, that is good. Pavel Walker, I apologize that my computer has been not working. Okay, that's fine. Okay, guys. So yesterday, you know what we did yesterday? Anyone is there to explain that?
We did.
Yes. Yeah.
Applications. We learned about the work formula and how we can do W equals F times D, F equals M times G, all that thing.
Good. Right, guys. And there are 2 types of work done. One is constant force, right? And another is the incremental force, right, guys? And I posted the videos on YouTube. So if you need some more help, we went over every different types of examples. So please try to look at that part and try to go through the things, clear your doubts. I just want you guys to perform well in the exam in the last test, because last test, that is article 7.5 work done, 7.7 fluid force and infinite series. So 5 or 6 articles are there in the last exam. So please guys, be careful, work hard. Okay, let me share my screen now. Did I share my screen? No. Let me share my screen. So the fluid force. All of you are able to see on the screen, guys?
Yes, sir.
Good. So the fluid force. Now, fluid force is the another completely applicable part of integration. Here we require some pressure. So pressure is nothing but force into area, or the other way around I would say force. The applied force is nothing but the pressure, whatever the pressure I am applying, pressure times area. The total area and the pressure. So total area and whatever pressure I'm applying, that is nothing but the force. The total area of an object and pressure I'm applying, that is the force. So pressure is nothing but force. Area or force is nothing but a pressure into area. So same way, now we are not talking about the pressure what we are applying, we are talking about the fluid pressure. So fluid pressure is given by let W, or sometimes it is called omega, capital omega, be the weight density, right? Density usually we denote by omega. So let W be the weight density of a fluid, the pressure P exerted on an object at a depth D in the fluid is given by P equal to pressure equal to density times depth, right? Density times depth. If you go over this example, very simple example is there, right? If you go over this example says that a cylindrical storage tank has a radius of 2 feet and holds 10 feet of a fluid with a weight density of 50 lb per feet cube. What is the force exerted on the base of the cylinder by the fluid, right? Please read this example twice, guys. A cylindrical storage tank, the tank is cylindrical, has a radius of 2 feet. Radius of 2 feet means radius, the upper part of the tank, cylindrical tank is nothing but the circles in, and if you increase one circle above another circle like this, and you are getting the cylinder. That means there is some radius because it's a circular portion. So radius is there, and that radius is given to you, that is 2 feet, and holds 10 feet of 10 feet of a fluid with a weight density, 10 feet of a fluid that is filled up in that cylindrical tank. With the weight density, the density of that fluid, we don't know what type of fluid is there, but the density is given, and that's what we want. We are not interested in knowing the things about the fluid, which type of fluid is there, but once the density is there, we are good to go. 50 lb per feet cube. What is the force exerted on the base of the cylinder by the fluid? Let me again share my whiteboard with you guys so that you can come to know this thing. Just try to memorize these data: 2 feet, 10 feet depth fluid, and 50. This is the density. Okay, guys, let me stop my sharing here and let me start with sharing the whiteboard. Okay, guys. So I can start like this. As I told you that I have a cylindrical tank. So my tank will look like this one. Cylindrical tank. It will be something like this. I'm sorry. That is the problem. I'm sorry, guys. Okay. What is this? So many of you guys have not submitted your homework. So I think now I'm tired of this. If you don't want to submit your homework and if you want to lose your grades, it's your choice, guys, right? How many times you want me to let you know these things? I think I'm tired of this. You guys are enough mature to understand things. It's your choice, guys. Those who have not submitted the homework, if you want to take this one easily, that's fine. Your choice, your life, your syllabus, right? Good, guys. So here's a cylindrical tank, and now the radius here is 2 feet. So this is my 2 feet. It has the fluid. Some fluid is there, and that fluid, suppose it is completely full. And let me take this one is 10 feet. So this height is, I would say, that is equal to 10 feet. 10 feet. 10 feet. Okay, and then after, first of all, I want to find the force. So force is nothing but, what is force? You know that force is nothing but the pressure times area. That means I want to find the pressure. So pressure is given by E equal to W times D, right? Density times depth. Density is given to you 50 lb per feet cube. There is a density provided to you. Depth is given to you. Depth is, you can see over here, that is equal to 10 feet. That means I can write 50, this feet and 1 feet will get cancelled out. So it is lb per feet square. So pressure is nothing but 50 lb per feet square. What is the area? The area of a cylinder is given by pi r square. Pi r square. You can see my r is 2, so it is 4 pi. It is 4 pi. Let me plug these values over here in the force. So I'm going to get 50, and here it is lb per feet square multiplied by area is equal to 4 pi, and that is equal to 2000 pi lb, right? Because area is feet square, right? 4 pi into feet square, sorry. So here it is feet square. So this feet square and feet square will get cancelled out. So 2000 pi lb, that is the answer. Simple. Yes or no, guys? This is the answer. Any doubt? Guys, say something, please.
No, sir. No.
Thank you.
So it's 2,000 pi pounds of force.
Say again.
It's 2,000 pi pounds of force, right?
Yes, 2000 pi pound, that is the force. Okay, guys. So that's how we can solve this example. Let me go for the next one. Next example is look at here. Now we are going to find two types of force. One is fluid force on a vertical oriented plate. Fluid force on a vertical oriented plate. Let a vertically oriented plate be submerged in a fluid with weight density W, which will be provided to you, where the top of the plate is y equal to b. Top of the plate is y equal to b, and the bottom of the plate is y equal to a. So y equal to a to b, that means you are keeping the plate vertically, right? Force on a vertically oriented plate. Would you please give me one of the examples of vertically oriented plate, guys? Plenty of examples are there. Any practical example of vertically oriented plate? No? No? Are you sure? Okay, let me give you one of the examples. How many of you have seen the dam on the river? You know the dam?
Yes, sir.
So,
Yes, sir.
dam, the purpose of the dam is whenever you have a big fall, that means you can create one concrete building where you have some different kind of gates on the bottom of that building, and you can store the water on one side of that concrete building, that is called the dam. And once you store the water, and whenever we require some water at that time, we can open the door. You can open one door, two door, three. All the doors are like this. One door, second door, third door, fourth door, like this. If you open, suppose, first door, that means you are allowing the water, whatever you store it on the other side of that concrete building, other side of the dam, you are allowing that water to flow down to the other side, right? And that's how we can store the water, and when the time requires, suppose we don't have water or rain for a long period of time, at that time you can use that storage water, right, for the survival. So that's the purpose of the dam. Now, that dam that looks like this one, look at over here. This is the concrete building, and here are the gates. So if you want to open the gates, that means you have to, this is the gate, and you can take your gate like this, vertically, right? So whatever the force of water is there on the other side, so that's storage water. So that force that is working over here on this gate, and that is called the vertical force. So fluid force on a vertically oriented plate. So that is called the vertically oriented plate, and the fluid, water is the fluid over here for this particular example, dam example, and fluid force on a vertically oriented plate. So that is the example of the vertically oriented plate. Does it make sense, guys? Number of examples are there. This is one of them, very famous, or very, I would say, the exact example based on particularly for this theory. Okay, if y equal to 0 corresponds to the surface of the fluid. Now, once you have, suppose your storage, the water on the other side of the dam, that means there is one surface, right? Lots of big area is there in which the water is stored. And y equal to 0 corresponds to the surface. So that level top level that we consider as y equal to 0. So y equal to 0, that means that is considered as the x-axis. Y equal to 0 is the surface of the fluid. Then the force exerted on the plate by the fluid. Now that force, because water, lots of water is there, it has some force. So that force exerted on the plate, vertically oriented plate, that is given by the formula F equal to x equal to a to b, right? Again, b is the top part of the plate, a is the bottom part of the plate. So we are taking the integration vertically. So integration a y equal to a to b, omega negative y, ly, dy. Omega is the water density or density of the fluid, I would say. Negative y. Why negative y? Because the whole part y equal to 0, that is the level surface. That's the surface level, or I would say that is just ground level, right? So, and we are moving below the ground, and that's why it is negative of y. So that distance, because now we are taking one horizontal strip. Because look at, again, try to understand, guys, look at me, please, Rachel. See, this is the ground level. Vertically oriented plate is like this. Water pressure is over here on the vertically oriented plate, right? On the vertically oriented plate. And we are taking, because we don't know how much there, of course we know this thing, but suppose we take one horizontal strip over here. And that horizontal strip, you can choose anything. You can choose here, anywhere. It's not fixed. You can take that vertically horizontal strip along any of the portion of this y-axis. So this distance, whatever we have, whenever we have fixed the strip, right? That distance I would like to consider as y. But this y is below x-axis. And that's why I would like to consider as negative y. And that's why if you look at over here, your formula denotes something like this. It is given like this, formula equal to omega negative y. And ly dy. This ly is nothing but the length of the strip. That is the length of the strip, right? It will be a function of x because it is horizontal strip, right? So ly and dy. So that's why this formula makes complete sense. Another example I can give it to you. I told you, please give me some example. Do you want to provide me any example, guys? If you want to give me any example, please go ahead. No? Okay, let me give you another example. Have you heard about the submarines? I'm sure probably you guys have not seen the submarines, but have you heard about the submarines and how it works in the water, under the water? Right, guys? You cannot, if submarine is there under the water, you cannot see anything on the top surface of the water, right? But it is under the water. Now it is under the water, then suppose we have one window, submarine window. Of course, outside is simply water, or I would say the animals in the sea or the river, right? But so water is forcing on that circular plate. Usually if you go to steamer or submarine, the windows are in a circular form. Circular plate is there, right? So water is pressure is there, pressure of fluid is there, working on that window, right? Which is vertical window, because that depth is little bit deep in the river or in the sea. And that's why it is the another example you can say. So based on that one, you have to make sure how strong your window or wall of the submarine should be, right? Based on this fluid force and all these things, we have to, so that is required. Anyway, let me continue with this one. If I can give you plenty of examples, but we don't have time. I think 2 examples are enough. So in general, let dy represent the distance between the surface of the fluid. Surface of the fluid. See, I told you, damn problem. Just surface of the fluid, surface of the water, surface of the fluid, and the plate at y, one vertical plate at y, right? And the force exerted on the plate is given by W dy Ly dy. Some people, they consider, there are two actually formulas. Some people consider that as just negative of y. If you don't want to consider this formula, if you want to go for this formula, both are same. You must get the same answer. Don't worry about it. Yeah, usually we go for this one, but whenever we require this, we want to use this formula, I will let you know. But mainly this one, that depth, because it is below the water, all these type of problems, they are under the ground. And that's why we can say negative y. So this dy is just like your negative y over here. Okay, let's start the example. Oops.
Sir, one quick question. In the dam example,
I can't
so
see. Who is there? I can't
Veer,
see
sir.
that. What's the name?
Veer.
Who is there? What's the name?
Veer, sir.
Okay, go ahead.
So in the dam example, can you hear me now, sir?
Yes, I can hear you now.
So there's water on the other side that's putting pressure on the vertically oriented blade. Is there any pressure
Who
on
is
the
there?
other side?
Simon? I can't hear you clearly. Simon, who is there? Simon? Simon, who is there?
Never mind, sir.
Yes, sir.
I can't hear you. Please go ahead. Yeah, on the dam example, what is it? I'm waiting.
Is there any pressure on the other side of the dam? In this
No,
dam example?
all the pressure are there on the gates, right? On the other side of the dam, there is no, on just one side, because water is stored just on one side, right? So just
Yes,
pressure is there only this side. Are you getting me?
Yes, sir. Makes sense.
Okay, guys. Second problem, consider a thin plate in the shape. You can see over here, consider the thin plate, right? Okay. Let me just go back and try to explain to you. Just let me spend a little more time for the formula. Here, f equal to integration a to b w or omega negative y ly dy. This ly sometimes, as I told you, that is nothing but people are considered different authors. They are using different symbols. Some people, they say it is hy, each small h as a function of y. And that is nothing, the depth of the fluid at y. Depth of the fluid at y. Or other way around, it is called as the distance between the surface of the fluid and the plate at y. Difference between the surface of the fluid. If you want, you can write it down on a separate piece of paper. Difference between the surface of the fluid and the plate at y. And this ly, some people, some authors, they use the symbol small ly. Some people, they say capital Ly. That's fine. Doesn't make any difference. That is the horizontal length of the region. Horizontal length of the region. As I told you, once you consider one strip, that length of the strip, horizontal length of the region, or you can say strip at y. Horizontal length of the region at y. So please keep this thing in mind. Please keep this thing in mind. If you want, I can repeat. This density will be provided to you. X equal to y equal to b, that is the top part, ground level. Y equal to a, that is the bottom part of the dam or gate or bottom part of your plate. Omega is a density. Negative y, that is sometimes hy, that is the depth of the fluid at y, or you can say the distance between the surface of the fluid and the plate at y. Small ly or capital Ly, that is the horizontal length of the region at y. So please keep this thing in mind, guys. Example, consider a thin plate in the shape of an isosceles triangle. Now it is isosceles triangle. Again, the figure I have given you over here in your practice test, in the exam, figure will not be provided to you. And if you don't draw the figure, that means you are losing your points. Few people, they know this thing yesterday, because I graded your exam, and couple guys, they solved the examples, this Wasser and Cell method, without using any figure. I'm wondering how one could do this thing. I'm wondering, it's not absolutely not possible. I just got some points, just partial points. But in the final, probably I'm going to cut complete example. I'm not going to check that example if I find something like this. So please be careful, guys. Sometimes you cannot survive without figures. So you have to follow my instructions whenever it is required. When it's not required, that's fine. But suppose arc length, you don't want to draw the figure, fine. You can just plug the values and you can get the answer. Surface of revolution, fine. I don't want the figure. But for this Wasser and Cell method without figure, and you are fixing the range of integration without figure, is ridiculous. Don't do this thing, please. Okay, so let me continue with this one. So consider a thin plate in the shape of an isosceles triangle. Now my plate is isosceles triangle, is an isosceles triangle. I told you that your plate could be anything. It could be a rectangle, it could be a square plate, it could be a circular plate, it could be some kind of rhombus, it could be like what? Triangle, right? Isosceles triangle. It could be anything. Plate could be anything. Any kind of plate would be there. So consider a thin plate in the shape of an isosceles triangle submerged in a water with a weight density of, see, water weight density again is going to use 62.4 lb per feet cube. If the bottom of the plate is 10 feet below the surface of the water, now bottom of the plate, look at here guys, look at here. This is the surface level. Bottom of the plate is over here, means one triangle is over here, one triangle is over here. And this bottom of that plate, that is 10 feet below the surface level, that means this distance is 10 feet. That's what is given to you. This distance is 10 feet. 10 feet below the surface of the water. What is the total fluid force exerted on this plate? What is the total fluid force exerted on the plate? For this plate, you can say the base, because the plate is like this in the reverse form. So the height of the plate, you can say the top part and the bottom part of the plate is 10 feet. This plate itself is 10 feet below the ground level. This is 4 feet. So that means this from ground level to the top part of the plate, that is 6 feet, because 10 minus 4 is 6 feet. Are you getting me, guys? You have to fix one X and Y axis. Yes. So what I'm going to do, look at my cursor. I'm going to draw one dotted line like this, 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 till Y axis, means X equal to 0. So this is my X equal to 0 X axis, and this is my line Y. This distance from X equal to 0 to the top part of the plate, or Y equal to 0 actually, the top part of the plate, that is 6 feet, right? Because I divided exactly into two parts this plate, that means this radius is 2 feet. Are you getting me? This radius is 2 feet. Now I'm going to take one strip over here. I told you, you can take the strip over here, 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 just on one side. You can take the full strip too, or you can take just one side. I will let you know, I'm fixing my small ly using this horizontal distance of the strip, right? So that's what we are going to do in this example. So I just want you, all you guys, to please pay your full attention for this particular example. Once you understand this example, you will be done. You will be done. Please keep in mind this thing. We are working with water, and the water density is provided to you 62.4 lb per feet cube. 62.4 lb per feet cubic feet. That is the water density provided to you. Right, guys? So now let me start with this example. I hope you have this example in your mind. Just look at this example, read it twice so that I can change my screen. Consider a thin plate in the shape of an isosceles triangle submerged in a water with a weight density of 62.4 lb per feet cube. If the bottom of the plate is 10 feet below the surface of water, what is the total fluid force exerted on this plate? Make sense? Make sense, guys?
Yes, sir.
Yes, sir.
Good. Let me stop sharing this screen and let me start my whiteboard. Okay, so let me clear everything so that I can write the new part. Okay, guys, let's start. Let's start. So first of all, let me draw the picture. Whenever it is required, you have to draw the picture. So let me do something like this. Suppose I have one plate over here. So this is my ground level. This is my ground level, and my plate is something like this. My plate is something like this. I told you that I need my y-axis. So let me divide my plate into two parts, right? Just try to adjust this one. This is just make sure that you are dividing your region exactly into two parts, like this, guys, please. Looks like exactly two parts, right? Looks like two parts. Okay. Okay, that's fine. This 4 feet is given to you. That means this distance is 2 feet. So this is equal to 2 feet. This distance here to here at the bottom of the plate, that means this part that is given to you 10 feet. This is 10 feet, and this distance here to here that is given to you, that is equal to 4 feet. This is 4 feet. So naturally this distance that is equal to 6 feet. That is equal to 6 feet. Right, guys? This is equal to 6 feet. Okay. Now my formula, I'm given my water density, W is equal to 62.4 lb per feet cube, lb per cubic feet. And my fluid force, so you can write F, that is equal to Y equal to A to B, and here it is omega, and then negative of Y, and then L of Y and dy. negative of y, that is the distance. So let me first fix my strip. So this is my strip. This is my strip. And this distance from here to here, from the top to the middle of the strip, this is nothing but my, you can say hy, or that is equal to, assume that that is equal to negative y. That is equal to negative y. So whenever in this example, if I say negative y, that means we mean by this distance or depth from the surface level, water surface on the ground to the strip on the plate, right? And I'm interested in finding this x. This is the x which I'm interested in finding, and that will provide me my Ly. How can I find this x? Yesterday we did one example in work done that whenever you have a cylindrical portion, your x remains same throughout the cylinder. But when you are triangle, your x changes every time. That means you don't have any other choice to get without or except to get the equation of this line. Let me change the color so that probably you can come to know this thing very easily. Where is the spotlight? Here's a formula. Okay, let me use this color. Right now, if I want the equation of this line, I want the equation of this line. How can I get this equation of the line? For equation of the line, I have to fix the number. This is my y. You can see over here, this is my x equal to 0, right? There is no part of x, so x equal to 0 because this point is 0, 0. This is my 0, 0. X is equal to 0. And depth is 10, so it is negative 10. That is my 1 point. Same here. This is my 2 feet. Radius is 2. So 2 and, or you can say this, yeah. And 2, and here it is negative of 6. 2 and negative 6. Out of these two, any one of these points I would like to consider as x1, y1. Second one I would like to consider as x2 and y2. So that I can first find the slope. So slope m equal to y2 minus y1 divided by x2 minus x1. Right? So I can write like this, y2 minus y1 divided by x2 minus x1. y2 minus y1, that is nothing but negative 6 plus 10. Am I right? Negative 6, that is y2 plus minus plus 10. And here it is 2 minus 0. That is equal to 4 by 2, and that is equal to 2. That is equal to 2. So equation of line. Now, what is my Ly? Just make sure that my Ly is nothing but 2x. Ly is whole distance. This is whole my Ly. Whole part is my Ly. But I am finding just this part over here right now. I'm finding only this part. Right? But once I have my x, then after I can multiply it by 2 to get my L of y. So whatever we are doing right now, that is just to fix our Ly. Once you find a slope, then after I can go for the equation of line y minus y1 equal to m times x minus x1. My slope is equal to 2. This is my m. Slope is equal to 2. Y minus y1. Y1 is equal to, this is my y1. Y1 is equal to negative 10, so y plus 10 is equal to m times, so it is simply 2x. Am I right? Because otherwise it is 0. So what is my x? I can write x equal to y plus 10 divided by 2. Agree? That is my x. So if I multiply it by 2 both the sides, I'm going to get that is equal to y plus 10. And this 2x is nothing but my Ly. You can see it's a function of y. It's a function of y. So my Ly equal to y plus 10. Whatever Ly I got over here, just let me go back and plug this value over here. So that is equal to integration. Now first we fix the range of integration. So integration runs from, that is the plate. That's the plate. So y runs from negative 10 and goes up to negative 6. So y runs from negative 10 and goes up to negative 6. Omega, that is equal to 62.4 lb per feet cube. Question? Hello? No voice, please. 62.4 lb per feet cube, right? And here, negative of y, this negative of negative I would like to consider out. Okay, let me take this negative out. And here it is now y. Ly already I'm having y plus 10. And here it is dy. Ly is y plus 10 and dy. Now the ball is in your court. It's very simple. Negative 62.4. Negative 62.4. Now I can write integration y equal to negative 10 to, and here it is y square plus 10y. Guys, I'm getting some noise, please. I don't want this noise. And here it is dy. Here it is dy, right? if you take this one, now solve this one, so negative of 62.4, negative 62.4, and here integration is nothing but y cube divided by 3 plus 10 times y square by 2, and my range of integration is negative 10 to negative 6. So that is equal to, please keep your calculator handy, guys. Please keep your calculator handy. Negative 62.4, and here, first of all, I would like to consider this 6 cube. 6 cube is, I think, 6 are 36 multiplied by 6 is 216, right? So it is negative cube, negative is there, so negative 216 divided by 3 plus, here it is y square. So negative 6 square is 36, 36 multiplied by 10 is 360 divided by 2 is 180. So that is equal to 180. So that is my first part. That is my first part. Minus sign. Now 10 cube, 10 square is 100, 10 cube is 1000, negative sign, so negative of 1000, and divided by 3. Plus 10 square is 100 and 1000 divided by 2, right? So 1000 divided by 2. Bracket complete. Open the bracket, take the LCM, whatever you're going to get, that is your answer. You are going to get some answer in terms of your decimal, that's fine. So that is your answer. And all your units will get cancelled out. So that is just you're going to get just one number, and that is your answer. You don't have to use any unit because all other units will get cancelled out. If you plug it over here, 62.4 lb per feet cube, and then y, that is in terms of feet. Okay, this one is in terms of feet and area. So all this feet and feet square, so feet cube and this feet cube will get cancelled out. So everything will get cancelled out, and finally you're going to get one number. So that's the answer. That is the answer. Any doubt in this example? If you have any doubt, please let me know, because this is the most important example. Once you understand this example, probably you're almost done with this article. You are almost done with this article, please guys. So let me make a partition so that you can come to know things. Any doubt? Any doubt?
Sir, I got a message from John Marshall that his Wi-Fi wasn't working, and that's why he's not here right now.
Okay, fine. Just send the message to him to see the videos after the class before you come tomorrow to the class.
Yes, sir. Yes, sir.
Yeah. Okay, guys. So I hope you don't have any problem, right? Shall we go for the next one? Yes or no?
Yes, sir.
Okay. So let's go for the next one. So let me stop sharing this one. Now let me again go back and share my screen. This example is over. Now let's go for the next one. Third example. Find the, now see the figure is not given to you. Find the total fluid force on a car door. See car door, another example. It is something like this. Suppose there is a heavy rain, right? Extremely heavy rain. And if you have parked your car outside your home, and suppose you are living in a little bit lower location, and because of the heavy rain is increasing, the level is increasing, water level is increasing like this, and finally, or your whole car there is under the water, right? So again, the fluid force is working a vertical plate. Vertical plate means the glass of the door, car door. Another example. Find the total fluid force on a car door submerged up to the bottom of its window in water. Right here, where the car door is a rectangle 40 inch long and 27 inch high. Right, guys? Car door is a rectangle. So find the total fluid force on a car door submerged up to the bottom of its window, in water, where the car door is a rectangle, and it's a car door window, is a rectangle window, 40 inch long and 27 inch high, right? Again, let me share my whiteboard so that you guys can come to know the solution of this problem now. So let's start. It's 40 and 27, right, guys? 40 and 27. May I erase this example? If you want.
Sir, can I take a screenshot real quick?
Yes. Yeah, if you want to take picture, please go ahead, take the picture. And then after I can go for the next one.
I'm good, sir.
Okay, thank you. So let's go for this one. So clear all drawings and let's start with the new problem. Okay, so again, let me start with my car door problem. Car door problem, this is this, right? And suppose it's a rectangle, so I would like to consider this one in this format. This is my x-axis and this is my y-axis. Here I can write. Now, first of all, I want to make sure what is the length or height. So 40 inches, that is equal to 40 divided by 12 feet, right? 40 divided by 12 feet, and that is equal to how much? 12 threes are 36, right? And then again 4, again 3s are 36, 36, 36. So it is going on. So I'm going to get 3.33333. So let me write 3.3 bar, right? Or if you want, you can write 3.33 feet, 3.33 feet, just for the sake of convenience. Same here, 27 inch can be written as 27 divided by 12 feet, and that is equal to 27 divided by 12 means 12 2s are 24, 24, 5, 6, and 7, 3. So I'm going to get 2.3 and 0. So again, 12 2s are 24 and 6, so it is 5. So 2.25 feet, right? 2.25 feet. Good. Now here, this is my x-axis. This is my x-axis. This itself is my x-axis, right? Don't count this one. This itself is my x-axis. Okay, what is this point? Now, if I consider one strip over here, this is my strip, suppose. Now, this time you don't have to divide into two parts because you are not finding the equation of line. So just this is my x-axis, and this distance from the center of the strip to the surface, that is equal to negative y. So I can write hy equal to negative y. Hy equal to negative y. Let me fix these points. This is 0, 0, of course. Once this one is 0, 0, this length is, how much length? Length is 40 inches, right? So I would like to write, let me write length. And here it is width. Width. So length is this one. That means this distance is nothing but 3.33 and 0. 3.33 and 0. This distance is nothing but, yes, please, it is 2.25. So 0 and negative 2.25. 0 and negative 2.25. And naturally, this point is nothing but 3.3 and 2.25 negative. Negative, of course. Negative 3.3. And by negative, this is x-axis, right? So x is same distance. So 3.3 positive and negative 2.25. Negative 2.25. Once you have this information, then after you can start your example. Then after you can start your example. So let me start with this one. So my fluid force is nothing but integration omega and then Ly, negative y, Ly and dy. Y runs from A to B. That is equal to integration y is equal to A to B. What is your A? A is nothing but your bottom part. So negative, you can say from here to here, right? So negative 2.25 to 0. So negative of 2.25 to 0. Omega is water density 62.4. And then after negative of y, what is negative y? As it is, right? Negative y. And Ly is nothing but this distance. Ly is the distance from here to here. This distance is nothing but your x, and this x itself will work over here Ly because we are not dividing into two parts. So that is your Ly. So your Ly in this case will be how much? What is your Ly, guys? Your Ly is nothing but, yes, 3.3. Your Ly, let me write it down over here just to make sure. Your Ly equal to 3.333, right? That means I can write how much? 3.33, that is equal to, shall I write in fraction 10 divided by 3 just to avoid this rational number, or rational number, I mean to say 3333. Let me write just 10 by 3. Make sense? Because 10 by 3 is 3.333. That is equal to 10 third. 10/3 and dy. So that is my Ly. This Ly is my 10/3. Now just simply solve this one. And here it is integration divided by 3 is also out. 10 is also out. And here it is y. So integration is y square by 2. Let me remove the integral sign. And range is negative 2.25 to 0. Negative 2.25 to 0. Use this one, second fundamental theorem. You get one number. That by itself is the answer. No wise, please. Any question?
Sir, I have a question.
Guys, I'm getting some noise. Please mute your speaker. People are getting disturbed. Please. Yes, Rachel, go ahead.
So 62.4, is that a constant or is that number going to change depending on the question?
It depends. It depends on the fluid. Here, the fluid is water. And water 62.4 is constant always. That density is constant. If you remember, if you look at the practice test of work done on second page, I gave you, or first page, I gave you different kind of fluids, water, gasoline, mercury, right? And different constant, different density constant of different fluids were provided to you, right? So there's always constant that will be provided to you.
Thank you, sir.
Good. Any other question, guys? Any other question?
You said we'd be given those values on the test?
Yes, this value will be provided to you. This value will be given to you in the test. Sounds good? Is it okay?
Yes, sir.
Okay. Shall we go for the next one, guys? Shall we go for the next one? Say something.
Yep.
Okay. Let's go for example number, now let me first stop sharing this one and let's go for our problems. So, okay. Example number 4 is at here, there's a bottom, exactly same as the previous example. Rectangular, this distance is given to you. You can consider, see this one, the distance is given to you. You can just continue this one, divide this two into this one into 2 parts, right? And then take one horizontal strip over here. Try to fix these points. This point is, this is 1 feet, means y is 1. So here y is -1, y is -1. And this is 2 feet, 2 feet. That means if you divide into 2 parts, your x is 1. So this point is, this point is 1 and -1. And this point will be, this is 1 and this is 2. So it is 3. So here it is 1 and -3. So here it is 1 and -1. Here it is 1 and -3. Right? 1 and -3. And then take the strip over here. The strip will be your, and distance from here to the strip, that is equal to -y. So your integral fluid force will be, I'm giving you the answer right now. Fluid force is equal to integration, y runs from -3 to -1. Water density W is equal to 62.4 lb per feet cube, -y as it is, and distance here, this distance is given to you. Don't have to find your Ly over here. See, Ly is your whole, that is the length of the strip. Length of the strip is 2x, and there is 2 feet given to you. So your Ly is 2 feet, and you're done. Simple. Ly is 2 feet, right? So integration -3 to -1, 62.4 water density W or omega multiplied by -y multiplied by Ly is 2 times dy. So 62.4 times -y times 2 times dy, solid, and the answer. Let's go for the next one. Does it make sense? Alexis.
Yes, sir.
Does it make sense?
Yes, sir.
Hey, somebody is over here, Judith's friend, who knows Judith, because Judith did not take her second exam and she is not here since last 3 days. So I'm just wondering, I'm worried about her. Is she good or something wrong with her? Somebody is here to try to figure it out and give me the reply tomorrow. If Judith's friend, someone is there, please. No one is there? Okay, I think I need to request John to send the email to her, and I can do the same thing for her. Yeah, to her too. Let's see. Okay, next example, example number 5. Look at the example now again. Look at the example, guys. Find the fluid force exerted on a given plate submerged in a water with a weight density of 62.4 lb/. Now again water, same weight density, but now this time your plate is triangle, but it is not placed in a reverse way. It is placed in a, the top part is the peak of the triangle and base is bottom, right? So please keep this thing in mind. And this is 5 feet, 5 feet. Height of the triangle is 6 feet and the base is 4 feet. Okay. And water density is this one. So we are going to consider this part and try to solve the example number 5. So let me just stop sharing this one. And again, let me go for the whiteboard. May I remove this part, guys? The previous example? I'm asking you.
That's fine, sir.
Thank you. Okay. So what was the data, guys? The data were, let me just do like this. Let me go for this one. And this is my surface level and my triangle look like this one. Triangle is over here. Let me divide this one into 2 parts. This one is given to you that is equal to 2 feet. So this distance is 2 feet. So I'm going to go over here. And this height is given to you here to here. That height is 5 feet. So let me write 5 feet over here. The height from the top of the triangle to the bottom of the triangle, this one, that is equal to 6 feet given to you. So this is 6 feet, right? So total that is 11 feet, total 11 feet. That means I can write, this is of course 0, 0. This is 0, 0. So naturally this is 0 and negative 11 because it is under the ground. So negative 11, 0 and negative 11. So naturally this is 2 feet. So this is 2 and negative 11, 2 and negative 11. So this distance, you can see here, this is 0 and this is negative 5. 0 and negative 5. Again, triangle is there. That means if I consider any strip like this, that means my choice of strip, it depends on us and it varies at different levels. Different levels, I mean to say that if you consider strip over here, 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 that varies, right? So that's why we need to go through, just like our previous example, previous example, we need to go through the equation of line to fix my x. This equation of line, that is particularly to fix your x, and x means you are fixing your ly. So this is my x, this is my x, 2x, the whole strip. Let me change the color. The whole strip, that is my ly. This distance is my L of y. This is L of y. Right, guys? So Ly equal to 2x, you can say Ly equal to 2x. Okay, again, the slope m is given to you, that is equal to x2 minus y1. Again, I can, let me fix any one of the points as x1, y1, second point as x2, y2, and I can find slope equal to y2 minus y1 over x2 minus x1. So negative 5 over plus 11 divided by 0 minus 2, so that is equal to naturally 3, right? So equation of the line, that is equivalent by y minus y1 equal to 3 times x minus x1, and y minus y1 is nothing but, yes, negative 5. So it is y plus 5 equal to 3 times x, x1 equal to 0. So it is 3 times x. So naturally I can write, yes please, what is my x? So x is equal to y plus 5 divided by 3. Y plus 5 divided by 3. Am I right, guys? This is, I think, 11 and here positive and
Yes, sir.
negative. I'm sorry, my bad. Negative. So slope is negative because, yeah. So it is negative. So naturally, here it is negative. So negative of 3x. So let me multiply it here by negative 3. That makes sense. Okay. So my Ly equal to 2x and 2x equal to negative of 2/3 out, and inside the bracket it is y plus 5. Inside the bracket it is y plus 5. So this one is done now. So let me now start my example. I think blue pen is really very light. So let me go for the red dark color so you can visualize the things very clearly. Okay, so this is example number 5, and fluid force is given to you. Fluid force is equal to, so integration y is equal to bottom of the plate, that is equal to negative 11, and top of the plate is equal to negative 5. That means I'm moving from y equal to -11 to -5. Water density is given to you 62.5. Negative of y, that is the distance, negative of y, that is the distance from here to here. That is, you can write hy equal to negative of y. So negative of y. And my ly already I fixed. My ly is equal to -2/3. -2/3, let me pull it out. So -2 divided by 3. And here I can write y plus 5. So y plus 5 and dy. Y plus 5 and dy. So that is equal to -2/3 out multiplied by 62.4. And here it is. This negative and this negative become positive. So let me write positive over here. And here it is integration y square plus 5y and dy, where y runs from -11 to -5. And I think now the ball is in your court. It is 124.8 divided by 3. If you multiply 62.4 multiplied by 2. So that is this number. And here the integration is y cubed by 3 plus 5 times y square by 2 and -11 to -5. And now just use the second fundamental theorem of calculus and you can get the answer. Does it make sense?
Yes, sir.
If you have any question, you can ask me. Or you can take the picture like Alex is. Right?
So where did you get the 2/3 from?
2/3 is from here. Look at here. This is my x. Agree? Here to here, that is my x. Yes or no?
Yes.
So whole distance, because I divide into two parts, so whole part, that is my 2 times x. Agree?
Yes.
Yes or no?
Yes.
Right? How can I fix my x? To fix my x, to find my x, I have to take the equation of line. Make sense?
Yes.
Asking you. Yeah. So equation of line. So to find the equation of line, first I require slope. To get the slope, I have to have 2 points. I have to fix 2 points. One is x1 y1, second one is x2 y2. So I found my m slope, and then after I plug this value of slope in the equation of line, y minus y1 equal to m times x minus x1. Y minus y1 is fixed over here. This point is fixed. I found my slope. Let me just plug the values. That means I'm going to get my x, make a function of x equal to y plus 5 divided by -3. Make sense? I can write the same thing as, look at over here, -1/3 and y plus 5. Make sense?
Yes, sir.
So that is my this x. But I'm looking for my whole strip, ly. So I have to multiply it by 2. So I just multiplied by 2 here. So that is negative.
Okay. Thank you.
Any doubt, guys? Any doubt? Shall we go for the last example? Shall we go for the last example?
Yes, sir.
Okay. So again, let me stop sharing screen and let's go for the last one. Yeah, let me take this example, number 6. And number 7, I think, let me leave that example for you. I'm not going to solve all the examples. Number 7, there is homework. Let me solve this number 6. It says that find the fluid force exerted on the given plate. Submerged in the water with a water density of 62.4 lb per feet cube. Don't you think this is a kind of example of submarine, as I told you? See, under the water, circular plate is there. Find the fluid force exerted on the given plate. Submerge the water with the weight density, this one. Right, guys? Weight density, this one. Okay. So let me start with this one, guys. We will just keep this figure in mind and let's find my, whenever we have a circular plate like this, whenever, yeah, that is not the rule, but usually what I do, whenever we have circular plate under the water, circular plate, not triangle, not rectangle like this, but circular plate, at that time, I'm not going to use that negative y, I'm going to use hy. I'm going to use hy because I don't know, but I'm a little bit more convenient, comfortable with hy whenever the circular plate is there. If it is triangle, rectangle, I can go for, triangle, I can go for the equation of line and I can fix my x. Or if it is a rectangle, I don't have to do anything. Immediately I'm getting my x. If it is a square, I'm good to go. But when it is a circle, usually I prefer to go for the second formula of the fluid force, that is Hy. Let's start with this one. Oops. So let me again stop sharing and let me go through the whiteboard. Okay, so let me erase this part and let's go for the next example. Let's go for the next example. So first of all, let me draw the picture. This is my surface. This is my surface and my window is somewhere over here. Window is somewhere over here. So whenever you want to, now things are slightly different. You can do negative Hy, negative y also. But I just would like to do this example by the other method so that you can come to know this thing. The second formula works equally like the first one, right? Like this. Now look at here, guys. This distance is given to you that is equal to 5 feet from the center of the circle to the surface layer. This distance is given to you that is equal to 5 feet. So let me write 5 feet here. That is equal to 5 feet. The radius is given to you that is equal to 2 feet. This radius that is equal to 2 feet. So I would like to write this is 2, 0. See, I consider this as my x-axis now, not this one as my x-axis. In all previous examples, I used this one as x-axis. Now this one is x-axis. Or as I told you that you can consider this one as your x-axis and you can consider this distance to here to your strip that is equal to negative y. Both the ways you can do this example. Both the ways. Let me just change the pattern this time. Otherwise, as I told you, same thing. Okay. So let me take one strip over here. Suppose this is my strip. This is my strip. You can take the strip anywhere. Okay, this is my strip. Usually I consider my distance that is from my x-axis. Previously my x-axis was the surface. Now I have my x-axis over here. So usually I consider this distance as my y. Now let me say y because it is above x-axis like this. Look at over here. Let me consider y. So that means naturally my hy, that is this distance. So hy is nothing but hy equal to, yes please, whole distance from here to here was 5. This is y. So this must be 5 minus y. This must be 5 minus y. Right? And this distance is my x. This is my x. This distance is my x. And the whole distance is 2x. So my Ly, that is equal to 2x. But I want to fix my x first. How can I fix my x? See, fixing x is more easier than the triangle. Why? Because you know the equation of the circle. X square plus y square equal to 2 square is 4. Right? So x square equal to naturally y square minus 4. So x equal to square root of y square minus 4. X equal to square root of y square. I'm sorry, did I do anything wrong? Yeah, it is 4 minus y square, my bad. 4 minus y square. 4 minus y square. If you multiply it by 2, so this is my x. If you multiply by 2, that means here you multiply by 2, here you multiply by 2, and this is your Ly. This is your Ly. Right? So my picture is done. Let me find the fluid force now. So fluid force equal to y equal to, how can I fix my y now? Look at here, this is radius 2. So naturally this one is 0 and negative 2. This is my x-axis, 0 and negative 2. This one is 0 and 2. This is 2 and 0, and this is negative 2 and 0. Y runs from negative 2 to 2. So y runs from negative 2 to 2. Excuse me. Y runs from negative 2 to 2. Okay. And then water density. Water density is equal to 62.4. 62.4. Hy is nothing but 2 times square root of now 4 minus y square. That is my, Ly. That is my Ly. This is my omega, Ly. And Hy, h of y, that is equal to 5 minus y. 5 minus y and dy. 5 minus y and dy. Now, there is a special trick to solve this integral. Look at over here, guys. first of all, let me take this one and this one out. So 124.8 is out, sorry, 124.8 is out. Okay, integration, y equal to negative 2 to 2, y equal to negative 2 to 2. What is left out, guys? 5 times square root of 4 minus y square minus 4 minus y square. Let me write two integrals, that will be better for me. Negative 2 to 2, here it is 4 minus y square, square root sign, and here it is negative sign, I took it out, so here it is y. So y times, and here it is dy, and bracket complete, and bracket complete. So that is equal to 124.8. 124.8. And how can I get the integration of this part, guys? You know integration is nothing but the area, right? You can use the formula for a square minus y square square root hyperbolic function, right? You can do this thing. Otherwise, this is just the area, definite integral. So area of a circle is, yes, pi r square. Agree? So area of the circle is pi r square. But I'm working with semicircle. Look at over here. This is 4 minus y square. That means it's a semicircle above x-axis. Negative 4 minus y square is a semicircle below x-axis. It is above x-axis. So let me write 4 minus y square. And semicircle means divided by 2. So that is equal to pi by 2, and radius is 2. So here it is 4. So I'm going to get 2 pi. So this integral is simply 2 pi. This integral is 2 pi. Minus. Here you can use u sub 4 minus y square equal to u. So negative 2y dy, that is equal to du. So naturally y dy, that is equal to negative 1 by 2 times du. And you can see here my y and dy is there. So that is negative 1 by 2 into du. So negative 1 by 2, I can pull it out, and integration. And here it is u to the power half and du. U to the power half and du. Make sure your range of integration is negative 2 to 2 with respect to y. So take the integration and convert to y. So this integration will be, this is u to the power 3 by 2 divided by 3 by 2. And the range is negative 2 to 2. But y, please. And here it is 1 by 2, negative sign. So this can be written as this 2 and 2 will get cancelled out. You're going to get that is equal to negative 1/3 out. And u was square root of 4 minus y square. So square root of 4 minus y square, sorry. Let me remove this square root sign. And here it is, yeah, 4 minus y square. What was my u? Oh, u equal to 4 minus y square, right? To the power 3 by 2. To the power 3 by 2. 4 minus y square to the power 3 by 2. And plug the range and get the answer. Don't forget to add with this one, this 2 pi here, and then multiply throughout by this one. So that's how you can get the answer of this one. Any doubt? If somebody says that, no, I want to go for the other way. Yeah, that sounds good. Let me change the color. Probably you can come to know this thing. Oops. Okay. Suppose somebody says like this. Right? And this is my strip. And you can consider the distance from here to here, that is equal to hy equal to negative of y. Hy equal to negative of y. You can consider like this. Hy equal to negative of y. Right? Circle is there. So naturally equation of circle is x square, but because this distance is given to you, that is equal to 2, and circle is there. So this is also 2. Right? So x square plus y square equal to 4. This thing, this one works exactly same for here too. For this one too. This one works exactly same for this one. Right? Yep. So and you can work like this. Okay, guys. So either way. Either way. Example number 7, that is just similar to example number 6. Just do it yourself. And I think that's all about your, I took several kind of examples based on the fluid force. So all is done. You want to start the new chapter today? If you want, I can start the new chapter. Otherwise, we can start tomorrow. New chapter, that is the last chapter, that is the infinite series. So first of all, we are going to see this sequence, what we mean by the sequence. We will be solving different examples, properties of sequence, all these things, then the examples of sequence, and then after we will jump to the infinite series. Just keep in mind this thing that sequence is nothing but a function whose domain is a set of natural number, and sequence is always identified using the codomain. If your codomain is natural number, then it is called a natural sequence. If codomain is or range is a real number, your sequence is called a real number. If it is Q, it's called a rational sequence. If it is Q complement, it is called sequence of irrational numbers. If it is suppose complex number, range is a complex number, sequence is called the complex sequence. If it is suppose M, it is called a sequence of matrices. So sequence is always identified by its range, right? And sum of the sequence is nothing but the series. So if you sum up all the sequences, that is a series. So keep in mind this thing, guys. And what you want? I just asked you and I started with the chapter, but I think let me take your opinion. You want me to start the new chapter? It's already 9:10. If you want, we can start. If you don't want, we can stop here and we can start the new chapter tomorrow. Choice is yours. Yep.
Tomorrow.
Okay, I don't mind. All of you agree with him?